Hey guys, welcome to 5.3. I'm going to be talking about how to factor difference of squares. And there are actually three very easy to identify characteristics to help determine if it is a difference of squares. So in the last two videos we talked about how to FOIL. So that's expanding and simplifying two binomials. In 7.2 we talked about how to find your common factor, your GCF factor, and then actually proceed through the common factoring steps. And then in this lesson, we're learning how to factor a difference of squares. Okay, so your three steps in determining how we know if it's a difference of squares is actually very straightforward. Okay, so what I've just highlighted here, you'll notice that the box that I just created is a situation where we have two terms. Okay, so our first term is a squared, our second term is b squared. The second thing you'll notice, there's a difference in between the two terms, so meaning you're subtracting. Okay, and the last thing you'll notice is its terms that are in your binomial are perfect squares. Okay, so you might ask, what's a perfect square term? Perfect square terms are values that could be either letters or variables, or they can also be numerical values that can be squared, and as a reverse can also be square rooted. So for instance, if we have a square and we know inside that area is 9 centimeters squared, what does that tell me about your length and width, given that it is a square? Well, you would hopefully say that means each side is 3 centimeters around, because I know 3 to the power 2 is 9. Okay, if I change that number to 16, and I said, well, what would the dimensions of a square be if its area inside of it was 16? Well, you would say it would be 4, because 4 squared is equal to 16. Now, as you can see, I can continue this pattern, 5 squared, 6 squared, 7 squared, and knowing your perfect square terms, which is essentially what all of this, review is for, identifies that this is in fact a perfect square term, so meaning you can factor it as a difference of squares. Okay, so if you just look at this little diagram in example 1, this just basically reviewed how to FOIL. Okay, so if we have x plus 3, x minus 3, very quickly we would work through first, oops, starting too much, x squared, outer, negative 3x, inner, positive 3x, and last, negative 9. So what you actually notice is our terms minus 3x plus 3x make a zero pair, and that zero pair actually cancels out the terms that are presently there that have a common variable of x. So this means once you simplify, you're just left with x squared minus 9. So if you consider it set up, this is actually how we multiply through FOIL, but if we started at the very bottom here, which is our product, I can actually factor this using difference of squares method to figure out what that would be as a factored equation. Okay, and how I would do that is I would basically just take the square root of each term. So for instance, the square root of x squared is just x. The square root of 9 is just 3. Okay, now you'll notice in terms of our setup, I would have as a finish x minus 3 and x plus 3, because our format of how difference of squares factoring looks like is right here. A squared minus b squared will factor into a minus b in brackets, a plus b in brackets. So the same terms, they'll still be a's will be identical, the b's will still be identical. The only difference is one has a minus, one has a plus. So how you start is what I highlighted here in green. How you finish, that's what you hope to get as a product once you factor it properly. When two binomials having the same terms but opposite operators in between are multiplied together, you get a difference of squares. Okay, so for instance here, you'll notice our A term in this case is x. Okay, our B term in this case is 1. So if I square both terms and put a minus sign in between them, my product will just be x squared minus 1. Okay, let's try the next one. If I look at my A term, that would be an x squared. If I look at my B term, that would be a 7. Because it's a difference, I put a minus in between them. And if I actually were to square 7, I would be left with x squared minus 49. Okay, so why this is really important, 2x squared minus 3 squared. This shows you how to actually do the reverse of FOIL, or that word that I keep mentioning, which is to unmultiply. Okay, so in this one, if I had 2x and then I squared that, 2 to the power of 2 is 4, x squared, it's just x squared, and then 3 squared would be 9. Okay, and last but not least, let's see if we can do this one in our head. If we square the A term, 5x squared would be 25x squared. And if I square the B term, 2 squared would be 4. Okay, and then we know that we slap a negative in front of it, and then that's basically done. Okay, now the way the questions will look like will be set up differently, so I'll go through that, but first let's just review how to square root. Okay, so remember the square root button on your calculator looks like something like this. Okay, what's inside of it might be different, so let's see, hang on, let me get my calculator. The square root button actually has a box where we're asked to fill in that box. Okay, so if we were to take the square root of 9, we would get 3. And this is because 3 squared is equal to 9, or a square has dimensions of 3 around. Okay, the square root of 100 is 10. The square root of x squared is just x, because x multiplied by x, which both have exponent 1, keep the base, add the exponents, that gives you x squared. Okay, and then if we wanted to find the square root of 25x squared, so you have your coefficient, you must square root that, so the square root of 25 is 5. You have your, excuse me, your variable, which is x squared. The square root of x squared is just x. So the square root of the whole term itself would be 5x. Okay, this knowledge is very necessary in working through today's lesson. Okay, so let's get to some actual questions and see what it would look like. So basically, this is on working backwards, so factoring. How do we get to our final step? Okay, so this is actually what a question would look like. We would have x squared minus 9. So essentially what you can do on your side sheet of paper when you guys are working this out is saying, well, what's the square root of x squared? What's the square root of 9? I know the square root of x squared is x. I know the square root of 9 is 3. So this means that x squared minus 3 squared, like what I was doing in the box up above, would be the rearranged equation, right? That is equivalent, which is why it can be set equal to. And as a difference of squares, how you factor it is placing your A term. Let me highlight my A term. It's in both binomials. Your B term, which is 3, which is in both binomials. But once again, you have a plus and a minus in both the binomials. Difference doesn't matter if you have a minus first or a plus. Okay? So let's see. Let's do a couple of them. You could actually do a lot of these using mental math. Okay? So for instance, the square root of x squared is just x. The square root of 1 is 1. So as a factored form, I would have x minus 1, x plus 1. Okay, so you'll notice the binomials are beside each other, and each binomial has a minus and a plus. Okay, square root of x squared again is x. The square root of 25 is 5. So you can write it this way. Square root of x squared is x. Square root of 81 is 9. Oops. Okay. I'll just go down them, but again, you can always pause the video, try them yourself. But they get actually kind of fun the more that you do it. Okay, so we have to make up our own. Okay, so I'm going to make up some tricky ones, and I want you to see if you can follow with what I'm trying to express here. What if I had it the other way around? What if I had it as 16 minus x squared? So that's the exact same binomial in a sense as above, except I switch my a and b terms. Well, so that means that you have to switch your a and b terms in your answer. So the square root of 16 is 4. The square root of x squared is x. And then we repeat the binomial for the second one. Just different signs. Okay? Now let's get a little crafty here. What if I had 100 x squared minus 49 y squared? Okay, so think about it. We're going to do the exact same thing that we did earlier. So we're going to square root 100x squared. We're going to square root 49y squared. Okay, so think the square root of 100. Yes, of course, that's 10. Square root of x squared is just x. This represents your a value. Okay, 49y squared, square root of 49 is 7. Square root of y squared is y. This represents your b value. So as a factored equation using your difference square steps, you would write two binomials, one with a minus, one with a plus. You write your a term, which is 10x, and then your b term, 7y. Okay, so what you would have is 10x minus 7y, 10x plus 7y. I'll write it again just because I had such a small space and I want to make sure that you see my writing without any issues. Okay? So our rule, write a rule for factoring a difference of squares. Okay? So if this was our rule, we have x squared minus smiley face squared, right? Our a term, our b term, we square root each term, write them as two binomials. Remember, one with a minus, one with a plus. So for our a term, the square root of x squared is just x. The square root of our b term, which is the smiley face, is just a smiley face. Okay? One is minus, one is plus. That is factored completely. Alright, it's a pretty straightforward lesson. Okay? I'd like you to try these 4 questions. Alright? I also got some sweet treats. I've been doing a lot of baking at home. Maybe you guys have been trying some new recipes. during this quarantine period. But like we've been doing, I'd like you to do these 4 questions here and post them on Edsby under the submit button, just so I can take a look at how you're processing at home. Okay, like always, please do not hesitate to ask some questions if you need some extra assistance. At some point next week, you might be given a little assignment just to kind of see how everything's going. We just have one more section, which is 7.4. It's a little tricky, the 7.4. However, again, I believe in you guys.